Hello and welcome to the Basic Statistics in R OSX video tutorial for Econ 4650. The objectives of this video tutorial are that you will be able to install R, identify and change current working directory, calculate statistics using R, create a scatter plot, and upload your output to Canvas. There are two texts available, either works. There is the normal or regular text and the short or custom text for this course. Text references from the films will be for the short or custom text. The first thing we want to do is go and download R. So we're going to go to cran.us.r-project.org. And we're going to go ahead and go down to download R for Macs OSX, and we're going to click on this R 3.0.1.pkg, and we're going to save the file. So having downloaded R, we can go ahead and install it. And if you go on and select the package that you've just downloaded, it will give you this dialog. And just keep moving through here. And the standard installation should work fine for us. So, having installed R, we can go ahead and open up the Applications folder and find R there and run it. And we're going to see the R console, and down at the bottom of the R console is the prompt with a flashing cursor, and this is where we're going to be entering our commands. The first thing that we need to talk about is the current working directory. So the current working directory is where R goes and looks for any data files which you'd like to bring into it, and it's also where it saves your workspace image, which is where it's going to put any data or object files that you create during your R session, and we'll talk about that more in a bit. So the first thing we're going to do is figure out where the current working directory is. So if we say get get wd, short for working directory, and open paren, R will automatically close the paren there on Mac computers, which is nice, and you hit enter. It'll show you your current working directory. Yours should look similar to this, with the exception of your username there instead of mine. So the next thing that we want to do is go ahead and try and change the current working directory. This is useful if you have a data file that you'd like to bring into R that's saved in a different folder. So we're going to say set wd open paren quotation mark, and then go ahead and type in the directory that we would like to change it to. So in this case, I'll change it to a subfolder of Brian called R. And to confirm that that went through, we're going to type in get wd again, and it's going to return where the current working directory is. So we can see there that it has been changed. One important thing that I'd like to bring up is that commands in R are case sensitive. So if I type in get wd with a capital G, it's going to go ahead and return an error. If you would like to fix an error, you can go back into the history of commands that you've already done in R by using the up and down arrow keys. So if I hit up twice, it'll take me back to my previous command that did not have the miss caps in it, and you go ahead and hit enter, and then it'll run. So that's just something to keep in mind. Errors are pretty common in R sessions, and it does not do any harm to the program at all. So you can just go back into the history of commands and run it again. So having done that, we're going to go ahead and practice some basic calculations in R. So R can be used as a basic calculator. If you type in 2 plus 2, it'll return the answer there. Or 2 times 3, it'll give you that. You can do 2 to the third power with a caret key. R can find the log of a number, so you can say log of 2.71821, and it'll return a number that's almost 1. This brings me to another important point. If you'd like to change your R session so that the output better matches what's on the basic statistics in R text on Canvas, you can go ahead and say options digits equal to 4, and that will tell R to show at a max 4 digits for each numerical output that comes out from a basic command. So you can check that by entering that command again of the log, and there it'll show you 1. So that's something to keep in mind. You can also nest commands within other commands in R. So if you type in log of 1 exponential, so log exp 1, that'll return 1. So that's just an example of putting functions within functions. And now we're going to go ahead and input some data from the text. This is found on page 9 of the short text, or chapter 17 in the regular textbook. And this is heights from a random sample of US women. And we're going to call this data capital X. And so we're going to put a space and then a less than symbol and a dash. Oops. Less than symbol and a dash. And so that's going to tell R to create a vector called X, and then we're going to assign something to this. So we're going to use the small c command, which is short for concatenate or combine. So C parenthesis, and then you can go ahead and we're going to type in a sample of that data. So 61, 63.5, 66, 68.5, and 71. And so if we want to check and see that R knows it's there, we can check what's listed in our workspace image by typing in ls and open paren. And you'll see there on the lower right hand side there's a capital X. So that X is our vector that we just created by combining that string of numbers and assigning it to that variable name of X. And R knows that it's there, so if you type in a capital X, it'll spit it back out at you. So once again, we just checked the workspace image, which just holds all of the objects that you create during your R session, such as this vector X. And then we just typed in a capital X to bring the vector back up to us. So now we can manipulate this data. So the textbook states that the mean of the data is known to be equal to 66 inches and a known standard deviation of 2.5 inches. That's the data from which this sample is taken. So we can go ahead and calculate the standardized z-scores of this data fairly easily. So if we type in a capital Z is equal to our vector we just created, capital X, minus the mean of 66 divided by the standard deviation of 2.5. Now we've just created a vector called Z, which should have the z-scores in it. So let's check on that here. Excellent. So we can see the z-scores there. And R can also be used to calculate the mean, variance, and standard deviation for this particular sample of data. So if you were to type mean of capital X, it'll return the mean. VAR for variance of X, it'll return the variance, and SD for standard deviation, and it'll return that. So keep that in mind. Now let's assume that the heights are distributed according to the normal distribution with a mean of 66 and standard deviation of 2.5. We can have R randomly sample from this distribution. So let's create a sample of 100 draws. So we're going to call this sample of draws capital X100. So we're creating a new vector here. And we're going to do the less than sign in the dash. we're going to use the R norm command, and we're going to ask it to take 100 draws from this normal distribution with a mean of 66 and a standard deviation of 2.5. So what this command is telling R is to take 100 polls from a randomly created normal standard distribution with a mean of 66 and a standard deviation of 2.5. And it's actually pseudo-random because R will use the current date and time as seeds to create the distribution, but we'll talk about that soon. Anyway, so now we've created this vector x100 that consists of the 100 poles from this distribution. So again, you can use R to find the mean of that, as well as the standard deviation of that. Again, your numbers might not match up with this, and that's fine. And we can see what a simple histogram looks like for this data. So we're going to say HIST, capital X100. And that'll open up in a pretty giant window, so you can go ahead and readjust that so you can still see your main workspace. Move it over here. And as I said before, when you do this on your computer, you're going to get different results, and that's because your random draw is different. So we can have the same draw by setting a seed. So if we say set.seed 100, and then you create a new vector that has polls from a seeded rnorm command. So we're going to say x100a, and we're going to say rnorm paren 100 polls with a mean again of 66 and a standard deviation of 2.5. Now if we find the mean of this, it should match that, which does match what's in the text. So that's great. And find the standard deviation of that. Oops. So there you go. As I said before, commands are case sensitive. So there you go. So now it found the standard deviation, and we can again do a histogram of that. And that looks pretty close to what's in the text. I could scale it differently by adjusting the window, but that's fine. R has a command for determining quantiles of data. So if you said quantile of x100a, then you could tell by this that, for example, the median value of the data would be 65.85. So now we're going to go ahead and do a distribution with a larger draw. So let's say set.seed 666, and we're going to call this zdraw. And once again, we're going to do the rnorm command. We're going to ask it for 20,000 polls or draws, and the mean is going to be equal to 0, and the standard deviation is going to be equal to 1. And we're going to find the mean of zdraw. Excellent. And once again, we're going to find the quantiles of this set of data, and we're going to tell it to look for the quantiles in zdraw, and then we're going to ask it for custom probabilities of the quantiles. So we're going to say the probabilities of, and then we're going to use that C command again. So prob space equal to C, and we're going to do 0.01, 0.05, 0.5, 0.95, and 0.99. And so you can compare this draw with the theoretical values for our requested percentiles. which should be respectively negative 2.326, negative 1.645, 0, 1.645, and 2.326. And then we can do a density plot of the large draw too. So let's do a plot. And again, this is when you're going to use a nested function. So you're going to use the plot command paren and then density to ask it for a density plot of what? Of z draw. And I spelled density wrong, and that's fine. And there's the density plot. So up to this point, we've gotten data into R by manually typing it in and assigning it to a vector. And what we're going to practice now is different ways to bring data in to R from external sources. So the first thing that we're going to do is go ahead and download a XLS file from, or Excel file from the publisher's website and convert it to a .csv file, which is what R likes to use, and then bring it into R. So if you get on the internet and you go over to pearsonhighered.com /studentmund, then you go down to datasets and find the datasets for the book. In this case, we're looking for chapter 17, which is what serves as our introductory chapter in the short book. And then Excel and stats. And then you want to go ahead and open it with whatever spreadsheet program you have on your computer. LibreOffice in this case, or Microsoft Excel will work fine. And you can see the data here. And you're going to go ahead and save it as a file that's a CSV. So if you go down here and find .csv, and I think I'm going to put this in the R folder that I found here. So put it in some folder and remember where you put it. And we're going to use text CSV format. That's fine. And then if we go back into R, then we can go find it. So right now, let's check what our current working directory is. So we're going to say get wd, and I need to change it to the folder that I saved the file in. So I'm going to go set wd, and I'm going to change that again, just like we did in the beginning. Oops, I forgot the / in front of users, so careful about that. And now we're going to type in dir with a open paren, and it'll close it. And this is going to tell us everything that is in our current working directory. And as you can see, our file, stats17.csv, is right there. So that's great. So now what we need to do is read the file into R. So come up with a name that you want to name the data. So in this case, I'm going to follow along with what the text did and say data 17. And you're going to do that less than sign again with the dash. And you're going to say read.csv. And then you're going to put the title of the document that you're trying to read in quotes. And write the title exactly as it appears, paying attention to caps and the like. And you're going to put a comma after the quotation marks and say header equal capital T for true, and this tells it that the first line of information in the CSV file are the headers, so it won't treat them like data and just form new headers on top of it. So now if you type in data 17, R will show you the data that you just brought in. So as you can see, we've got there, the columns are observation, number, price, and square foot. So anytime you have R display data like this, it's going to show you the whole data set, or data frame as they're called in R. Data frames in R are what's formed when you read a CSV into R and call it something. It's basically R's way of storing tables. So this data frame is relatively short, so I can see the whole thing here, but if you had a really long one, R would literally spit out the entire data set at you. So you could say head, paren, and then data 17, and then R will show you like the first 6 rows of data and the headers. And if you said tail of data 16, data 17, R will show you again the column headings and the last 6 rows there. So now one other thing that I'd like to bring up is that there are a couple different ways to get R to show you specific data items that are, within the frame. So let's say that you wanted to see what the square foot was for the 6th house. So you would say data 17 and a $, and then type in the name of the column within the data frame, so SQFT, and then square bracket, and then you would say 6, and then so then it'll go and find data frame named data 17. It'll go to column SQFT, and it'll return the 6th row from that column, right? So that's one way to do it. There is another way to do it. If you typed in data 17 and then you had a square bracket, and then in quotes you put the row, so you would say 6, and then a comma, and then in quotes you would put the name of the column, so SQFT, and then that'll return the same number there. So there are a couple different ways to get this data, and I just wanted to show you that so you could start to get a feel for manipulating these data frames. It would probably be a good thing to practice. So now we're going to pull up some summary statistics for this data. So if you did summary open paren data 17, it'll list summary statistics for each column there. And if you want to do a scatter plot of the data, you would do plot paren data 17, and let's put the column of square foot on the x-axis, and then comma, and then we're going to say data 17 with a $, and price on the y-axis, and then that'll pull up the scatter plot as you told it to. There's another way to access the names or labels of columns like square foot and price. You can do what they call attach a data frame. So if you said attach data 17, then R knows that whenever you ask for some data from some specific column name like price, it knows that you're asking for it from that data 17 data frame. So now you can just say plot square foot SQFT and price, and it knew to look at data 17 data frame because you had attached it. It's generally good form to deattach it when you're done, so we'll do that in a second. I want to show you that you can also find the correlation between these two things fairly easily in R. So if you did COR and SQFT, comma, and price, you'll notice that this time I put a space after the comma, and before I didn't. In these basic commands, R can typically handle that, so it's not like you're going to break, the software. So anyway, it'll spit out the correlation there, so that's great. And then if you're done with the data frame as we are right now, then you just type detach data 17, which is kind of like the proper thing to do when you're done. Otherwise, future commands you do might be going back and looking at this data when you're really not too concerned about that old data. So Let's check again and see what R has in its memory or in its workspace image by typing ls open paren, and you can see it's got all this stuff here, including, if you look carefully, the stuff that we added, like capital X and Z and Z draw. So let's clear out the workspace image by typing rm paren list equal to ls open paren, and then R is going to automatically close those for you, so that's great. And then you hit enter, and it just erased all of your objects from your workspace image. You can check that by typing in ls. So it just blew those all away, and so that's just a way that you can clean that out. As you do projects and assignments, you'll notice that it gets pretty full. So again, keep in mind the workspace image, which we just cleared out, is always saved in the working directory that you leave the program in. So the next thing that I'd like to talk about is that in this class, some data will be easily available directly from the internet. So let's try and bring in a CSV file directly from internet URL. So in this case, again, we have to name the data frame or tell R what we're going to call this file that we're about to bring in. So we're going to call it data, and we're going to do the less than sign in the dash, and we're once again going to use that read.csv command and open paren, and then in quotes we're going to type in this internet address, which again is listed on the document in the introductory course module available on Canvas, but I'll repeat it here and hopefully not mess it up too much. HTTP : so we'll do content.csbs.utah.edu / squiggly fowls / econ 4650 / data / stats 17. Try and get the caps right. I didn't once and it didn't like it, so keep that in mind. And again, we're going to tell this that we're going to tell R that the first line is again a header. This is essentially the same file we just brought in. We're just practicing getting it. So and header equal to true, and hit enter. And it didn't give me an error, which is always a great sign in R. So let's type in data, and excellent. There it is. The last thing that I'd like to go over in this video is how to export your text data and plot data as PDFs and submit them up to Canvas. So on a Mac, to export your plot data from R, what you want to do is select the window that the plot's in and say File, Save As. And then you can tell it where to go, and it'll save the plot as a PDF, which is really convenient. You can see that here. It'll create a PDF that's basically the same size as the plot. And then for your text data, you can select your data, and if you do the keystroke Command C for copy, and then go into a text editor like Word or something like that, and Command V to paste. In Word, you can select File, Save As, and select PDF. In LibreOffice, you have to select Export as PDF. But once that's done, if you go into Canvas, you'll be able to go into Assignments and select the assignment. And once it's unlocked, you'll be able to upload your PDF files from this screen. Thank you. So moving on, Assignment 1 is available in Canvas in Modules under Module 1, Statistics Review, or the Assignments button on the left sidebar. The first chapter of the custom text, which is equivalent to Chapter 17 of the regular text, entitled Statistical Principles, is also available under Module 1 if needed. Further chapters will not be available, so please purchase one of the texts. And later modules may not differentiate between Windows 7 and OS X operating systems, but if there are relevant differences in the R commands or interface, then we will address them by filming separate videos. So here's one more shot of the two texts that are available. And we hope that by now you feel comfortable installing R, identifying and changing that current working directory, calculating some basic statistics in R, creating a scatter plot, and moving that output on up to Canvas. Thank you.